Welcome to Maths for All. I'm Aisling Flynn. This is Algebra 2.7, Simultaneous Equations 2. Solving simultaneous equations. So, if you're asked to solve this, what we look at is that we have two linear equations. Linear meaning our variables are to the power of 1, and we solve these in Algebra 1.5 using the technique of elimination. Okay, so we matched variables and we subtracted them to get 0. Okay, we removed one of the variables. And they gave us one value for x, or in this case it would be a, and one for y, or in this case b. And what they represent is two linear graphs, or two lines, and they give you the coordinates of the point of intersection. You can see that there's one point of intersection giving you one value for x and one for y. Okay, so moving on. This is the type we're working with now. If you're asked to solve that, what we have here are one linear equation, so with the variables to the power 1, and one non-linear equation. Okay, so you'll see squares, x squares or y squares, or sometimes multiplications, x times y. Okay, and we will solve these by using the technique of substitution. Okay, so elimination can't work here because you can't cancel y's with y squares. This time we're going to use substitution. Okay, we're going to get two values for x, and then you have to find two corresponding values for y. And what they represent is perhaps a circle with a line. You can see that there are 2 points of intersection. Okay, so we should get two values of x and two matching values for y. Or perhaps something like this. This is a parabola, and with a line, we get 2 points of intersection as well. Okay, so let's go through the process. Here's what we're asked to solve. On the top you can see a linear equation, and underneath you see a non-linear equation. So we begin with the linear. We're going to use the linear to write one variable in terms of the other. Okay, so what does that mean? It means you take your linear equation and you change it so that it reads x equals and the rest of the equation, or y equals and the rest of the equation. In this case, because I have one x, I chose to take 4y from both sides, and so we get x equals 17 minus 4y. So it's telling me x is the same as 17 minus 4y, or x can be represented by 17 minus 4y. Then we move to the nonlinear, and we will substitute this for x into the nonlinear everywhere that x appears. Okay, so look at the nonlinear. We have x squared plus y squared equals 34. So instead of x, we are now going to write 17 minus 4y. Okay, and that needs to be squared according to the equation above. We have to add y squared to that, and it's equal to 34. Okay, so we have substituted for x, and now you can see that there is only one unknown variable in our equation. So in essence we have eliminated x, so now we can solve for y. Okay, so what do we have to do? We have to multiply out that bracket, we have to square it, and we're going to end up with a quadratic equation. So multiplying the bracket by itself, this is what we get. You can pause and work it out on your page if you wish. Then we would add like terms together, and we would bring everything to the left. So the 34 appears as minus 34 on the left, equals to 0, so nothing remaining on the right. Okay, just simplifying fully, we get a quadratic equation in y. So now to solve that quadratic equation, this is what we have. We've really big numbers here. So I took a chance and just checked, can we simplify? Okay, can we divide by 17? And yes, I found we could. Divides the whole way across. So if that's possible, do it. Okay. Now it's your choice. At this stage, you could use the formula or factorize. Factorizing is quickest if you see them. So factorizing to get your two factors and solve by putting each factor equal to 0. You get y is 5 or y is 3. What remains to do is to find the corresponding values of x. So to do this, we return to the linear. We choose it in this form, makes life easy. And we substitute each of our two values of y to find the matching x. So on the left here, I've chosen to use 5. And on the right, number 3. We have to subtract, and we get x is minus 3 or x is 5. So these are the results of the simultaneous equations. We found two pairs of x, y. We had minus 3 with 5 or 5 with plus 3. So here's another example. This time the linear is on the bottom and the nonlinear is on the top. So we use the linear to write one variable in terms of the other. So this time I chose b because it's 1b, and b equals minus 2a minus 1. We then substitute this for b into the nonlinear everywhere that b appears. So that's what this looks like. So we have a good bit of multiplication to do. You can pause and take a page and work it out if you wish. And we should form a quadratic equation. So multiplying, and then simplify by adding like terms, and bring everything to the left, leaving it equal to 0 on the right, and we get this quadratic equation. Let's solve that quadratic equation now, and by factorizing if possible, it's quickest. Solve it by putting each factor equal to 0. We get a equals 2 over 7 or a equals minus 1. And we have yet to find the corresponding values of b. So we'll return to the linear, b equals minus 2a minus 1, and we'll substitute for each value of a. So on the left we're using 2 over 7, on the right we're using minus 1. So working those out, alright, using a common denominator there on the left, and we get b equals minus 11 over 7, and on the right we get b equals 1. So we got two pairs of values for AB as shown here. Now you try those, try doing the quiz Algebra 2.7 and your written exercises.